Welcome to today's Routing Table podcast. My name is Melchior and I'm here with my co-host Rick.
Hi.
Today's guest is Juniper Networks CTO Raj Yavatker. Welcome, Raj.
Hi, glad to be here.
It's a pleasure to have you. Could you shortly introduce yourself to the listeners?
Sure. I just started at Juniper as its global CTO, and my career in networking started in early 90s when I got my PhD in networking, and I have worked on different internet protocols, internet switch fabrics, protocols like RSVP, MPLS. Then I also worked on programmable network processors. We ended up creating a new product category called programmable network processors in late 90s. So I was the chief architect for that, and we shipped 4 generations of those products before the dot-com bust. And after that, many customers like Nortel, Lucent, Alcatel really had trouble. So Intel sold off that business. Then I started working on cloud computing. I actually worked with AWS a lot and other companies to create open platform, open compute project that comes out of Facebook. I was involved in that. Rack scale architecture to do disaggregation in a rack of servers. So I have had this journey of doing both system software, systems, and networking for a long time. I also spent time at VMware, where I developed a product from scratch called VMware Cloud Foundation. And that product now has an annual run rate of $500 million. And that product basically, it was the first VMware attempt to create a hybrid cloud with lots of automation, integrating all of VMware products to deliver hybrid cloud. And it could come up in half a day, as well as we automated day 1 and day 2 operations. Then I ended up at Google because Google Cloud has the world's best network, the largest networks. So there I was responsible for delivering both cloud networking products and cloud networking infrastructure, the virtual network infrastructure. So after Google, then of course I ended up at Juniper as CTO.
Interesting, you said you worked on MPLS.
Yes.
You worked with Greedy.
Yes, and his brother Vachaspati. Both the Compella brothers sort of are legends in networking industry.
Okay. Yeah. Can we find your drafts? You have to,
no, I didn't. I was not. I was more working on RSVP, and RSVP is integrated into MPLS. I even wrote a book on RSVP.
Interesting.
On internet quality of service using RSVP. And Juniper, even today, is the biggest user of RSVP for the core networks.
Interesting. And that was your during your time at Intel?
Yes, that's right. Intel, I went to Intel to start an internet technology lab because Intel wanted to make sure that open standards are developed as much as possible so that horizontalization of the PC industry computing continues into other areas. So all these things where you could have MPLS like core networks, RSVP-based internet quality of service was aligned to Intel's strategy to make sure that an open ecosystem is built.
Right. And then moving into the software world with VMware and then Google, did that require a lot of different thinking from yourself? Because
I was always a software guy.
Oh, right.
Even at Intel, I was responsible for software development. I did my own development. I was an individual contributor until I became a Intel Fellow, which is the highest technical position. So I'm mostly a software and systems guy. I never did a chip design.
Right.
So when we did programmable network processors, as a chief architect, I was defining the architecture and micro-architecture, but not the chip design.
Right. Makes sense. And how... I'm very interested in how you educate yourself on new technologies. If something like Google Cloud is coming up and then we need new network functions then in a virtual type of fashion, how do you educate yourself on new subjects like that?
So I think that I use 3 methods. First of all, I always keep track of academic research because a lot of the networking research in academia is very practical. If you recall, internet itself came out of the academic research. So going to academic conferences, reading the papers, keeping track of some of my friends in academia, that's number 1. Number 2 is always try to read as much as possible from trade journals, industry-led conferences, and so on. Because that's where I think what happens is people like Facebook or LinkedIn do put out what they're working on. Mm-hmm. And third, I think I have worked in the industry now for 25 years, so I have lots of contacts. So I'm very good network. So I try to talk to my colleagues and friends. And what happens is that technical people always want to share information, what they're working on, without giving away too much of the product information. So that becomes another good source of information.
I know you want to continue on the education part, but I'm wondering, you say share information. So how do you see open source development of software and protocols?
I think the open source ecosystem is the best thing that has happened to the industry, in my opinion, because now you have multiple people sharing and contributing ideas. In the networking space, software-defined networking started around 2008 or so. And that's the first example of also networking where we had open source software being made available with open flow and so on. I think that accelerated the disaggregation of software from hardware and creating really scalable architectures. And companies like Google took it to the next level. They really. So I think open source, Kubernetes, now Istio, before that SDN, Stacks, OpenStack, have been a great benefit to the industry, in my opinion.
No, I agree. I think that's a very good way to develop new technologies without having to go through a very lengthy process of making a product and things.
Yeah. And the credit goes to Linux, right? That's where it really started.
Right, yeah. Interesting.
In that perspective of evolution of technology, we're now so last year SD-WAN was the biggest hype we talked about. This year it's multi-cloud. What's next? What's your idea? What is after multi-cloud?
So we are not done with multi-cloud, in my opinion, because it has to be cloud agnostic. Then only it's truly multi-cloud. So that revolution still has to happen. And this whole Google Anthos initiative, where Google is doing the same thing that they did with Kubernetes, by putting out in open source cloud agnostic infrastructure with application level networking. So the next shift in networking, in my opinion, is away from traditional networking to application level networking. That will happen.
How do you see the impact of, because you spoke a few times, I heard you speak about machine learning and AI. Yeah. How do you see the impact of that on the evolution of multi-cloud?
So I think what has happened is that if you look at the traditional enterprise IT, they were very used to taking products from established players with professional services to integrate and the support being provided. So they never had deep expertise in cloud native kind of DevOps kind of a culture. And that's the biggest limitation today. So due to that, I think when you start bringing multi-cloud and cloud agnostic architectures, lack of expertise means you need to have a lot more automation, because operational expenses and complexity is far greater than simply taking, say, Juniper Fabric or Cisco Fabric or Arista Fabric and just maintaining it, right? So that's the biggest shift to automation fueled by ML AI. And machine learning and AI, unlike 5 years back, is no longer a science fair project. The kind of infrastructure, tools available, libraries available to develop machine learning models, to use machine learning. So it's almost becoming, the toolbox that's given to you. And if you apply machine learning, you don't even have to understand what the machine learning algorithms do. Whether it's k-means clustering, reinforcement learning, those are transparent to you. That transition, which is the whole ML ops industry, right? There's so many startups in ML ops, and that's becoming mainstream. Once that becomes mainstream, that will fuel the multi-cloud, cloud agnostic world, because there is no way for IT, either in service providers or in enterprises, to develop that kind of expertise overnight. Where do we want to be? We want to be able to have ML-driven diagnostics, remediation, and automation for other tasks. That sort of thing, like you said, is still a narrow application of AI/ML, right? But where the world is going, in my opinion, at home, for example, if you have kids, younger kids, they don't even think twice before talking to Google Assistant or Alexa. They think everything happens, right? I get up in the morning, I get my calendar, all my weather, the road conditions from. Similar thing could happen in networking, in my opinion. For example, I was working on a project where a company had 15,000 firewall rules. Nobody wanted to touch them. They only kept on adding them because they are afraid if they touch it, what will happen? But you could easily have, based on flow logs, you have 90 days of packet traffic logs. You could train the model, which will automatically start making firewall rules and recommending firewall rules. I can imagine saying that I can tell somebody in a natural language, in English, I want traffic from accounting to be allowed to go to finance, but not to any other VPC or virtual network. But Dave can only talk to test. And that natural language input can be translated into that. So there are different ways we can apply MLAI.
If I think back on my time as a network engineer, this would have sort of saved half of my week's work.
Half of the week of troubleshooting, yeah.
Exactly.
So if you look at the next generation of engineers then, as you said, if you have young kids now, they talk to Amazon or to Alexa to do anything in the house. What do you think that their work will be in when this becomes a commodity, right? I mean, if I get in my car, I start my car, I have no idea what's happening behind the scenes. But for a network, I know exactly what to do because I've learned that. I know what type of chipsets I have in my switches and in my routers. So what does a next generation engineer? How will he learn these technologies and how will he?
So I can give personal example, right? My daughter, who's now she calls herself machine learning engineer, right? She doesn't call it computer engineer or software engineer, right? But if you look at them, rather than focusing on low-level data structures and algorithms, those engineers are really talking about doing a lot more integration and developing user interfaces, applying machine learning to different kinds of problems. So I think the skill set required, I'll give a good analogy, I'll give you, that when I really started working first time on a computer, Fortran was the language, right? Fortran and then Pascal. We don't know about those things.
I started with BASIC, so...
Basics, see?
On the Commodore.
And now people do Go, Python, and skill set required is very different. And training required is also very different, right? Because a lot of things are abstracted away. But that's okay. Complexity of the problems you try to address is very different. Distributed system, disaggregated architectures require a lot more focus on scaling, understanding eventual consistency like semantics, right? Those are the new skill sets people will develop. So those will be required no matter what, because we are going to a different world, right? I was talking to somebody in a large enterprise customer. They want to expand their private cloud to have tens of racks. And that sort of distributed system doesn't come out of simple leaf spine network. You need to build different architectures. Machine learning cannot help you with that. You will have to have those skill sets.
Right. Right, there are still protocols talking to each other underneath it.
Yeah, exactly, yeah.
I thought that Tony P was going to solve that all with Rift. Sorry, Tony.
Of course, zero config. That's the end of the world. Yeah.
Of course.
So if we're looking in, if we're talking about the hardware side of things, right? So there's been some announcements of other companies around the world. So Cisco, for example, has been betting big on their own new chipset that they've made. Of course, Juniper is a big ASIC developer for many years. It's been our bread and butter and our unique value that we've had for a long time. If you look at the disaggregation that's now happening in the software space, how do you see the value of making your own chipset still being a very key differentiator in the market?
I think it's a very good question because merchant silicon is here to stay. Mm-hmm. When you look at data center architectures, switches can be built using merchant silicon. But when it goes to the core of the network, where you have to worry about specific type of either tail latencies, you do not want tail latency to be very high. You want certain amount of aggregation with internet quality of service. That's where I think the people will continue to develop chips for differentiation purposes. But the sum total of what you call the area addressed by merchant silicon is going to continue to grow. But it's never going to, I think, replace custom ASICs because it has not happened on the computing side. x86 is the standard, right? ARM or x86 now for computing. But look, what has happened now because of neural networks, now you have specific chips being done for inference engines, for training models, right? Nirvana, Mobileye, these are the companies which have found a way in which next to x86, you still need specialized chips, custom ASICs, to not just differentiate, to handle the scale, to handle the performance requirements, and so on. I think similar thing will happen in networking.
Right. Could that be caused because the increase in performance that we see in x86 is not exponentially anymore?
Increase in, Moore's law is come to sort of very stagnation, right? x86 cores are still very expensive. Right. ARM is trying to replace that. So if I have to assign 20 cores to do DPDK-based packet processing, that's very expensive, especially in the cloud, public cloud. Imagine that you're Amazon or Google or Azure. Every core that you do not use for customer VMs is the money left on the table, right? So you have to always balance that. So for example, Amazon develops its own NICs, right? Annapurna, the company they bought in Israel, that has been doing yearly cadence of smart NICs. Why do they do that? Because I think that sort of differentiation, it offloads the core cost.
Exactly. Is there any frustration that you see in frustration, maybe not the right word. Is there any technology that you see, all right, if we would have this available now, whether it's a chipset or if it's a software feature or a new programming language, that will enable us to get to that goal of a self-driving network or a fully automated machine-learned infrastructure? So basically the big step that containerization got with Kubernetes, for example, what is the next breakthrough
step
that we need?
Function. What's the next step function?
What's the next function in there that we need?
So I think the one thing I already mentioned, when you go to application level networking, the control of the network and goes completely to the developer, application developer, which is a big change. Because, it's scary to some extent. Because traditional networking, if you worked on networking, you're so used to thinking about 5 tuples, L7 processing, all that. Now suddenly all that is decoupled from network and how the applications are written. You don't have to worry about monitoring, security. So I think that's a big change. It's going to happen. I think how long it takes, I don't know, right? So that's one vector, I would say, in terms of step function. Second step function, which is going to happen, is that I think rather than going for what you call self-driving cars, which is the ultimate dream, which has many aspects of human psychology and how humans react to that, right? It's that, I don't know when we get there, right? We have been talking about that. We'll talk about that for the next 10 years. It will get there. But there are other places where AI, ML based infrastructure becomes such as commonplace as C libraries. Right. That will cause another step function where people will not think about how they design a system, but they will try to use as much of the ML AI, indirectly or directly, to make that happen. That will be the second step function, I would think. But whereas I think self-driving cars, anywhere you have human beings are involved, I think I've been looking at that Waymo experiment in Arizona where they have taxis, right? A lot of the issues are not about whether a car can make the decision of stopping or not, whether how people react to that. And that's a harder part.
Yeah, it's an argument you hear a lot from people, right? So it's giving away control, autonomy to a system. That's probably the most scary thing to do for us as human beings.
But there are other disciplines where it has happened. Anybody who operates nuclear reactors, they have complete automation. They do not rely on human being. They cannot rely on human being. Then nobody complains because that's something is a very closed loop system which is very well designed. So those examples will continue to come into mainstream, right? If I have electric grid, today electric grids, US may not have the most modern electric grids, unfortunately, but countries like China are designing smart grids where a lot of the things you do for electric grid, offloading, load shedding and all, are being done automatically. You don't need an electrical engineer sitting there and making calls.
Juniper has always been sort of a front runner in technology, right?
And challenger.
Yeah, and a challenger. So we had sometimes we've been too early with technology. Is that the space where we're in with AI machine learning now? In that perspective, that we're sort of still have to get used to giving away that autonomy and in our world having the network control itself?
So I think Gartner a few years back created something called technology hype cycle. Have you seen that, right? So I think we are past the peak in AI ML, in my opinion. So we are in the next that curve that goes. That takes a long time, by the way. So that's where we are. It will take time, but it will happen more specifically in certain areas faster than others, in my opinion. So smart retail, where those are the things where you can easily see automation happening using ML. But there are areas where it will take time. It will definitely, but I think we are past that peak of the hype. We are still in the peak of the hype with IoT, in my opinion. The 5 billion devices, 20 billion, whatever. But IoT is happening, right? At home, I have Nest, I have Ring Bell, all that stuff is there. So it will be getting there. But none of those use any AI ML. Those are just using standard algorithms to do the things. Once they start using ML, we'll see that's where the human interaction part, right? You don't want to come home and be surprised by something because somebody else made a decision for you.
In that perspective, late last year, I joined a hackathon with Greety, and we worked on quantum. It was a hackathon around quantum internet.
Yeah.
We thought of a routing protocol for a quantum network. But I feel that with quantum, we're still very early in that hype cycle, right? Mm-hmm. So companies are investing big, the promise is big, but we don't really see yet how to use it, what can it exactly solve, and how do we get there?
I think I have a very strong opinion about that, right? If you like somebody like hyperscaler like Google Cloud or Amazon, their internal infrastructure is completely under their control. They have everything. So they can introduce quantum computing slowly for crypto analysis, crypto and stuff like that. That will happen first because they have the resources, then they can afford to spend money on it. I don't see quantum computing becoming mainstream for quite some time because those are the walled gardens where huge advantages there. I mean, I was at Google, I can tell you, it's amazing what once you have complete control your stack, you have lots of freedoms. You can even invent your own protocols, right? I don't want to say, but encryption. You can have your own encryption algorithm. You don't need to worry about standardization to IPsec and stuff like that. So that's where it will happen, I think, initially.
So if we talk about these, that for example, Google has everything under control. They know exactly what the network's doing. They know exactly where traffic is flowing and how they should schedule their connections. So when do you believe that? I mean, that kind of technology can only be developed because they have a big engineering team. If you look at smaller shops around the world, when will that technology, or will there be a vendor that maybe make a product that can do so much things? Because I mean, we are very open with automation. We have a lot of APIs. Applying those APIs or actually making use cases out of them, that is where I feel that there's still a gap between what's possible on the box and what people are actually using it for, other than rolling out configuration templates and applying things.
No, I think we are at early stage of. I really strongly believe that a company like Juniper has a huge opportunity for differentiation in that space. Whoever masters that with really good automation, and you mentioned Google, right? A company like Google has lots of engineers, but they also have lots of automation. Software development methodology that Google uses has lots of automation for CI/CD pipeline and so on. But they tend to put it out in the open source. Once it is out in the open source, other people benefit from it. Mm-hmm. And that's where it starts coming into the mainstream. This happened with Kubernetes, it's happening with Istio, it's happening in other places. Right now I have a project in mind, and I'm reaching out to Intel and Google to say that, would you not work on it? Because, anything you want to do in Linux kernel, you want to get multiple partners. Mm-hmm. So I think that's how I see a lot of the things that those hyperscalers are developing come into mainstream. Another mechanism by which they come into mainstream, a lot of people leave companies like Google, Amazon to do startup. And what do? They take their ideas and they start applying to other problems. Yeah. And that's how the CI/CD came out, right? CI/CD came out because a lot of people who left Google started using that. Mm-hmm. And that's how it sort of became the mainstream. Right. I think similar things will happen.
Interesting. The project you were mentioning there, is that the one that you're also looking for engineers for? That you're hiring for?
Exactly. I think we have an opportunity to do AI ML based, something really cool,
Okay.
which is very practical and it helps our customers.
Interesting. Will it be open source or is it going to be a
It's
product?
too early to tell.
Okay.
We definitely want to take everything in open source and use it,
Yeah,
right?
yeah.
And I think which is because then we are obligated to some extent to contribute it back, right? And which is always a good sort of a virtuous cycle that you want to take advantage of.
I hear this is an invitation to continue to make a part 2 of this podcast in 6 months.
In 6 or 9 months.
Why not? By that time, I will have built a pathfinding team and so on.
Yeah.
And that LinkedIn invitation I sent out, I got tremendous response. Right? So that helped to create a hiring pipeline.
Interesting. We're going to follow that.
Yeah.
You brought the conversation back to Juniper. You're sort of the newest employee now.
Yeah.
We're now sort of veterans already.
Yeah.
So, what is your focus now? What are you gonna? I mean, you're sort of absorbing, I think, what's happening in the company and getting to know people, and you have a lot of meetings going on. But what's your first 100 days gonna look like?
Like
So
a
I
new
think-
president is always his first 100
Yeah, I
day
know.
plan, right? So-
Everybody has first 100-day plan, has to have. So I think my role model in my entire career has been Andy Grove, who was a great example of somebody who's always said, you need to have a vision, you need to have strategy, but you have to match it with execution. So my first 100 days, I'm trying to do 3 different things. First of all, I'm trying to get my team to decide what priorities we are going to identify. So we can say clearly what we are not going to do. It's very easy to say I want to do something. So getting those execution priorities and focus in the team is very important. I own some products. The second one, I'm going to partner with Andy and his team, where we should create more sort of a crowdsourcing kind of culture among our engineers, where they feel energized. They don't have to go to another company to get that experience. So I like the idea you said hackathon. I used to do those in VMware. They're very popular. Lots of the good things come from. So I want to start doing that, working with Kirti, Andy, some of his people. That we need to do. And the third thing I want to do is start some pathfinding projects which become future products. Because you have to always start seeding the things as soon as possible. And there's some trends I talked about today in my session, which are really important to Juniper. And we are in a good position to partner with others and deliver those.
Can you maybe, for the sake of the podcast, repeat the topics that you mentioned today?
Yeah,
in your
so I
session?
think there
Because a couple
are,
of
I said multi-cloud is a reality,
Yeah.
but whoever delivers cloud-agnostic platform is going to have an advantage. So using Anthos like open source ecosystems, Juniper in our collaboration with StackPath should be able to deliver something. 5G infrastructure spending is just ramping up this year. It's going to get a lot more next year and too. 5G requires mobile edge cloud because of the use cases at which 5G is targeted, because of low latency, high bandwidth. So there I think, again, if we can deliver both mobile edge cloud based on Juniper's virtual network functions, virtual networking, and also start participating in 5G private networks, both in Europe and US, because unlicensed spectrum is widely available for enterprises. And then I think the next step is to look at ML AI. The vision of self-driving, self-healing network is no longer a dream. AI Mist company that we bought has already shown that how you can pinpoint, literally, they can automatically diagnose, remediate, and they do using ML. I think we can expand that portfolio across our products. We can make a difference.
I agree. So are those if we look at the verticals that Juniper is oriented in, so SP, enterprise, and cloud, of course, what is a short-term gain for them in the next, let's say, 12 months that they say, all right, let's focus on that?
So each of them have adjacencies that we do not address today. And that's where we have to start increasing the seam, right? So we leave gaps, we leave seams around those. But we can find adjacencies in the next 12 months where you can start delivering more software products, because the future is software for us.
Yeah, for sure. Yeah. And we definitely see that now with disaggregation of
Exactly.
our software portfolio versus the hardware platforms that Juniper sells. So very interesting.
I want to quickly go back to where we started on the career path. A lot of engineers are sort of searching, should I become a manager or stay technical? And you started off as an engineer. You became one of the best engineers recognized as being a fellow. And now you're a manager. Or do you still feel like you're an engineer? How does it...
So I think I have always been more of a technologist. So until I went to VMware, I did not manage, right? Maybe I had a team of 3 or 4. But I think the VMware experience was they let me do a startup within VMware. Start from scratch, 4 people, grew to team to about 140, right? That was an experience I really loved it. I really loved it because product definition and delivering. And so when I went to Google, I had a choice to be individual contributor. So I took that latter path because I said, and Google truly has very smart engineers. I mean, I really feel like when I was in Berkeley, I had students and postdocs who were smarter than me. There's no clearly. I felt similar thing in Google, right? So there, I think taking advantage of those, but also guiding them was a good opportunity. Generally, I have been asked this question many times by people. Should I go into management track? Or I always tell people to follow their passion. I used to teach a class called Career 101, where how do you make the choices? Some people have really good people skills, or so-called EQ, right? They do much better being managers or leaders. But in technical field, as you grow more experience, I think being a leader requires managing the teams also. Unless you can outsource it to somebody and still do that. For example, once I was 2 in a box with another very good friend of mine, and he was very good at managing, whereas I was more on technical. That also works.
Last words. I know we're going to talk to you in 6 months again. We just agreed. So
Exactly, yeah.
No, I think I'm very excited to be at Juniper, and I think we have a huge opportunity to lead the transformation of the company and to be the leader for the next 10 years of networking. So I'm really looking forward to that.
Well, we're really looking forward to that too.
Yeah.
with that, Raj, thank you very much.
Thank
we'll
you.
talk to each other in 6 months, maybe earlier. If you have any questions, if you have comments, you want to reach out, feel free to email Rick or Melchior at routingtable.cloud and subscribe to the podcast.
All right. Thank you for listening.